This week we will talk about list, stacks, queues, and priority queues. Those are the typical data structures we will use every day. Um, so a data structure is, the terminology is seems it's something fancy, but actually it's just a way we organize the data. We know our computer memory, no matter how we save it, the memory it's just itself, it's just a bunch of cells like location, each byte with the locations, and we just need to save everything in a specific way and put it into the memory. And um, those data structures like queues or stacks, they're no matter what kind of operations it have, everything is just aligned one by one into that memory. So the difference between this data structure is just how we define these operations and how we access the data from this specific location from the memory. And we show that generic stack class last week, right? But actually, luckily, we don't need to define this class by ourselves. Instead, Java has this collection interface. You can see it offers all these these classes, and we can use it directly. So like queues and double queue, and also this list and set. We will talk about queues, list, and stack today, this week. And the next week we will talk about set and map. So list, it's just like the one we are familiar with, like array list. It's just a way to linearly store a group of data. And stacks we talked about before, it's like an elevator, first in, last out. And queue is very similar to stack, except it's first in, first out. So if we just draw a figure, so if it's, oh my God. If it's stack, it's just, there's only one way in or out. So because it's only one direction, so it's first in, last out. But for queue, it's more like a line. Yeah, just like the name shows, right? So it's like a queue. The first person going into queue, he or she will just stand on the very beginning of the queue, and second guy, third guy, all the way to the last one. And when we assuming we want to get some information from the queue, each time I can only get the number at the very beginning. That's why like first in, first out. So once I got information from here, for example, this memory is released, I can then access the information saved on the second place. So that's the difference between queue and stack. Priority queue is similar to queue, except each item, like each person, when it goes into this queue, it also has a priority. For example, if it's like the president of the university, she has the highest priority. Even if there's already several people in the system, when she comes, we will put it at the beginning of the queue, and she will be the first. And next time we visit this queue, she will be the first person got at the beginning of the queue. And because this stack or queues, everything, they are just they are under the collection interface. So we can actually, collection provide all these methods that are accessible for all these data structure. No matter what data structure we use, we can just using this method, for example, to check if the data structure contains an element or to add an element or check if it's empty, remove something, or check the size of it. Um, and the way to like initialize, I mean, create a data structure is also very simple if you use collection. So just similarly, like the array list one, we just use collection, and this string means the only string element is available, is allowed to put into this array and array list, and that's it. We can actually change this. So if it's array list, which means it's a simple list, we can change it to linked list or stack, and it will become a new another type of data structure. And also, collection provides this thing called iterator. Uh, so it's used to like traverse every element through from this data structure. And you can see from the iterator has three like method, has next, and remove. Basically just move from this location to the next element in the data structure and so on and so forth. We can just using a loop to access every element using the iterator. And you can see here, this is the script for initialize the iterator. And because it's, I mean, the data structure itself is string, so we also have defined string here. And which is, I mean, the iterator is, belongs to the collection interface. And just each time we check if there's still an element in that data structure. If yes, we just move to the next element and change that element to uppercase and print it out. Yeah, this is a very typical way to using iterator to traverse this whole data structure. Yeah, for example, this one, you just traverse every element and change it to uppercases letters. Another very convenient method is this for each method. It's similar to iterator, also used for traverse the data structure, except we can actually using the lambda expression to use this for each method. So this one is like for each element in the data structure, we will print replace it. I mean, convert it to uppercases and print it out. Yeah, that's this specific format for lambda expression. So basically, for this element, we do something for it. I mean, so yeah, that's basically about the collection interface. We can also, I mean, instead of using collection, I mean, the way to define data structure, there's also, we can use the different data structure directly. So the first one is list, which is the most simple and easy one. So it's just like a one-dimensional array, and you just save everything here, and you can use index to access all these elements. And there are two types of list. One is array list, and the other one is linked list. And you can see these are all the methods that can be work on a list. And the difference from array list and linked list is array list is just I get a continuous location from the memory, and for example, is eight memory cells from the memory, and just assign it to this array list. Then I can just manipulate everything. But the thing is, if I have 100 numbers, I can like dynamically create a new cells and cut them together. I have to create a new one and copy the existing one to that new one and do then do all the operations, which is very not convenient if you want to change the size. But for linked list, basically, I just create some random, I just get some random memory from the computer, and each of them are just linked by a pointer, just one cell linked to another. Assuming I have additional 100 numbers, I just create 100 new like cells, and I just link this one with the new one, and everything is just connect to each other. So
yeah, adding this, as we know that we can add some numbers or some data to it by using the methods, right? So array list is itself not fixed. So what is difference between like array list and
you can add it. It's just Java has those methods implemented for you. For you, it's just like add. You can add it, but at the end, inside the computer, they have to create a new location, copy, and destroy the previous one and do it. That's why. Because it's implemented to make everyone use it like conveniently. You don't have to do that. Allocate new memory, but inside the Java virtual machine, those steps are performed. That's why. Yeah. So yeah, it's fixed size and larger array has to be created and copied to it. But yeah, just like he said. Yeah, these are some specific because linked list is different from array list, so it has some new like a method you can actually for example this add first, add last, because it's a pointer, right? Usually you have a pointer at the beginning, you have a pointer at the end. You can add something at the beginning or add something at the end. That's like a more like a typical way to do it. If you, let's say I want to add a number between these two ones, actually you have to start from the beginning and go to this, just next, go to this one and then add it. That's also like one issue. Yeah, that's one issue of linked list. Like sometimes if you want to add something as in the middle, it will be slow. It's like each kind of data structure has their own advantages. Some data structure are fast in this type of operations, others are quicker in another kind of operations. So just depending on the problem you want to solve, you can choose different data structures. And also list also has its own iterator that has next, previous, very similar to the collection interface. So yeah, this is a very typical way to create an array list, and just you can create it like this way and input any number into it. And also, so yeah, this one is different. This is the initialization for linked list. So here I use object. So basically I can add a number or a string. That's because I don't specifically set it's a string. And also similarly, it has the iterator, and you can use has next to move to next, move to next. Yeah. So list, because it's belongs to collection. So the collection interface actually also provide many methods to work on this array. For example, very typical sort, yeah, and reverse a list, and copy, and also min max. These ones are specifically for list, but these ones are also okay for like a stack and queues. So yeah, we can just using the this method to do like a try reverse or sorted list. So yeah, any question about the list? No? Yeah. Another data structure is stack. We actually has already discussed it previously, right? So there's a new thing called vector. It's almost the same with stack, except it has some like when it's designed, it has some functions to like to remove errors if you want to. I mean, many process try to access the same stack at the same time. So yeah, if you are going to do some like database programming, vector might be a better choice. But for our daily like homework assignment, stack is completely okay. Similarly, they have these methods, and they can be used to initialize and access element from the stack. We saw this these methods
Do you have any restrictions to add a data type or cannot?
Sorry, what's your question?
Like amongst linked list and array list, do we have a restriction so that like we can add any data type, or is it a specific one?
It depends on how you define that linked list. You know, that object and a string, because it's also generic. I mean, the function is generic function. If you use object, you can add anything you want. If you define like using generics like a string or integer, then you can only input a specific type of value into it. We saw this method in that generic stack implementation last week. So these are very like popular or typical operations for stack. Basically, we just manipulate on the very top of that stack. To use the stack, so first we need to import stack, right? And secondly, we can just define a stack like this. The format is like just very similar to array list and all the other data structures. And after that, we can just push an item to it. Each time an item is pushed at the end of the stack, and we can use peek to get the top of the element, and pop also get the top of element. So yeah, queue is we talked here. It's very similar to stack, except it has this first in, first out data structure. And priority queue is just a queue with the priorities. And this, Java, the collection interface, they have this method for queue. But if you're using other like Python or other language, maybe the function is a little bit different. But usually, yeah, I think pull and the peek is very common. Offer, I can't remember specifically, but yeah, maybe in other language use another type of word to represent. But yeah, in this interface, offer is just put an element into the queue, and pull is just remove an element from the queue. There is also another queue called DAQ. It's called double-ended queue. So it's double-ended, which means so let me see. Yeah. So usually a traditional queue, you put something in it. It's just like this way, one by one, put it that here. But if it's a double-ended queue, like And also, oh yeah, by the way, we tell this beginning of the queue, we usually call it head, and the end of the queue is tail. But it's a double-ended queue. There will be two pointers, both pointed at the beginning and the end of the queue, so that we can access element at the beginning. We can also access element directly at the end. So which and also there for each usually a queue is implemented by a linked list. GPT? Yeah, I will upload after the course. Yeah, yeah. Oh, yeah. So usually the queue is implemented by a linked list. If it's like traditional queue, maybe it's there's just, I mean, each cell there's only one link between them. But for double-ended, there are two links, like this one connect to this one connect to this one. So you can actually traverse, I mean, forward from the beginning to the end, or from the end to the beginning. So yeah, I mean, people design this kind of a DQ deck or those things. Mainly, it's useful for solving some typical algorithms. Yeah, I mean, for everyday use, maybe ArrayList is okay, especially for Java. They have already implemented all those methods. I mean, sometimes you can tell you can feel the difference. I mean, at the end, maybe it's slower, but you can still get all these like manipulations, like remove first at last. But if you want to do something on lead code, some question might specifically ask you to use stack to solve it. Others might get using stack to solve it. So yeah, you can try to practice in the future if you want to find a job, and maybe these data structure you have there, you use them, find out they are very useful. So, and yeah, priority queue, I mean, it's just a queue with priority, and but see. If several elements they have the same priority, then they will be like randomly selected. So let's see an example. Here you can see this example, it just define a priority queue, and there's also a method that we can reverse this queue based on their priority. So because we didn't assign any priority for these atoms, so they will just be arranged by the by the alphabetic order. So let's run this one. You can see at first they are ordered by the alphabetic order of the first character. And if we reverse it, they will just sort it in a reverse way. So yeah, to determine the priority, actually, I mean, inherently, there is a method called comparator. If you automatically compare each element and determine which one has the highest priority. If we want to, like, I don't want to use alphabetically, I just want to use the length to represent the priority. I can just override this method and just override this compare method. Then next time priority queue knows how to determine the priority.